From the cumulative distribution function for the continuous RV, so random variable, so the continuous random variable x given below, find the probability density function, f, we use lowercase f sub x of x. So here we've got capital F sub x of x, and that's our CDF here. And if we take a look, it's made up of a lot of pieces. It's pretty common. So it's 0. The limit of a CDF is always 0 as you head to the very far left, and it's always 1 as you head to the very far right. So it's 0 up until -1, and that's when it starts to, I guess this would be a line rising a little bit, actually rising very slowly. And then at 0, it sort of levels off, and it's just a half for a while. And then we've got sort of a scaled parabola here, going up from 2 to 3, and then it's... So this is the shape of the CDF. That's not required to find the probability density function or anything like that. I just like sketching and understanding what's going on. Okay, so the relationship between the density function of a continuous random variable and the CDF is that the density function, the PDF, is the derivative. So really, to answer this, we just need to differentiate the individual pieces of our CDF. So let's copy it down. There's a lot of pieces here. We'll have 0, there was a 1/2 in the middle, and then there was a 1. I think it was x plus 1 over 2. And that was between -1 and I think it was 0. Then it was 1/2 for a while, and then there was that parabola. It was x squared. I know it was over a 4. I want to say, was it plus 3x plus 1? And it was like that, I think, between 2 and 3. But, of course, we'll go check all of this. Especially that parabola piece, the quadratic. So it was minus 3x and it was plus 4, but other than that, I got everything right. Okay, good job. Good job, my memory. All right, but let's go and fix that. So it's a minus 3. And it was plus 4. And just because I'm not going to go back and look at it, let's do one last double check. Yes, everything looks good. Okay. So now, I might say, all right, the f of x, the one that we want. It's always hard to say, do you always say capital F? Do you always say lowercase f? The density function is the derivative of the CDF. So we just have to come along here and differentiate each piece. Actually, I need a little bit more room for that. So we'll differentiate 0, which is just going to be 0. X plus 1 over 2. We'll differentiate 1/2. Differentiate the quadratic piece. And finally, differentiate 1. I'm going to drop copying the if part. We're just worried about the differentiation. We'll bring those in a moment. Okay, so the derivative of 0 is just 0. The derivative of 1/2 is just 0. The derivative of 1 is just 0. These are constants. Right? So these represent the CDF not changing. It's fixed. It's level at those points. Okay, x plus 1 over 2. What I could do, take out the over 2, and we'll be left with x plus 1. The derivative of that is just 1. So we get 1/2 times 1, or 1/2. Okay. And then we can do a similar sort of thing with the quadratic piece. Take out the 1/4, the dividing by 4. And then it's a little easier to differentiate that. So the constant goes away, and then the 2 comes down. So we'll have 1/4 2x minus 3, or maybe we want to write it as 2x minus 3/4. Okay. So it's going to be 0 in a lot of places. So when x is bigger than 3. Got that wrong. So it's going to be 0 when x is bigger than 3, when it's between 2 and 0, and when x is less than minus 1. We can summarize all of that by just having, and this is a pretty common thing to see, just having an equals 0 otherwise. And then we have a little bit between -1 and 0. And that was my 1/2. And then it was 2x minus 3 over 4. And that was between 2 and 3, I think it was. Let's double check. But then we can just summarize, because, yeah, the CDF was 0 for a bit, and then a half for a bit, and 1 for a bit. But all of that, when you take the derivative, is just 0. So it's 0 for these non-interesting pieces here. And we'll just double check. Yes, between 2 and 3, and -1 and 0. So there we go. Even though, if we go back and look at the original question, even though the CDF had lots of pieces, a lot of them were constant, so that all just sort of collapses to having a derivative of 0 in the density function. So if we go back, the density function that we have actually looks a little simpler. But there we go. There's our final answer after everything is done and differentiated.